Individual throttle bodies, or ITBs, are a performance induction upgrade designed for high-revving engines. By featuring one throttle plate per cylinder, they maximize airflow and throttle response, making them a definitive choice for serious performance builds.
What are ITBs? In a conventional engine, a single throttle body feeds a shared plenum. ITBs eliminate the plenum entirely, giving each cylinder its own dedicated throttle body that draws air directly. This is similar to multi-barrel carburetors, but uses modern electronic fuel injection, common in performance platforms like the BMW S50, S54, and Toyota Beams. How do ITBs work? They function by eliminating the volume between the throttle and the intake valve. Without the need to pressurize a shared plenum, atmospheric pressure is present at every cylinder, allowing air to reach the engine almost instantaneously when the throttle opens. The performance impact of ITBs is significant. They provide dramatically sharper throttle response, improved volumetric efficiency at high RPM, and an upward shift in the torque curve for a wider usable power band. Additionally, their design reduces throttle body inertia, resulting in faster breathing transitions. When comparing setups, a standard single throttle plenum buffers air to smooth out engine pulses. ITBs, however, allow each cylinder to breathe independently. Effectively, ITBs are the electronic fuel injection equivalent of multi-barrel carburetors, replacing float bowls with precise fuel injectors.
Tuning ITBs requires a specific strategy known as alpha N, because manifold pressure pulses can confuse standard sensors at part throttle. Instead, fuel tables are indexed based on throttle position and RPM. This requires careful calibration, especially near closed throttle positions, and some systems may blend alpha N with speed density for better flexibility. Installation involves precise geometry tuning. Runner length is your primary variable for the resonant ram effect, where shorter runners favor high RPM. Bore diameter should be matched to port flow, while velocity stacks help smooth airflow. For those needing a smoother idle on naturally aspirated setups, a balance tube linking the runners is often used. Which engines benefit most? ITBs excel on high-revving naturally aspirated engines like inline 4s, V6s, and V8s, especially those operating above 7,000 RPM. While possible on forced induction builds, the setup is more complex, requiring the ITBs to be placed downstream of the turbo with a short plenum. At a glance, the trade-offs are clear. ITBs offer superior response and high RPM power, but they come at the cost of higher complexity, more difficult tuning, and often a reduction in low-end torque. They're generally best suited for race applications rather than stock-compliant street driving. In summary, ITBs are the right tool for race cars and high-revving builds, where maximum top-end performance is the priority. However, if your focus is daily drivability, strict emissions compliance, or limited tuning expertise, you might think twice, as they sacrifice low-end smoothness for those specialized high-performance gains.